Okay, question number 1. They're asking us to match the following. On the left hand side, you have CaOH twice, NaCl, CSO4 dot half H2O, CaCO3. Okay, quickly tell me the names of these things. CaOH twice jo hai, is there any common name for that? Tell me common names of CaOH. It is called as slated lime. You can also form milk of lime from that, which is used for whitewash. You can also form lime water from that, which can be used as a test for CO2. Lime water can be used as a test for CO2. Similarly, baryta water is also used as a test for CO2. Okay, NaCl sodium chloride here, which is common salt. CSO4 dot half H2O. Any common name?
POP.
POP, plaster of Paris. Okay, what is gypsum?
2H2.
CSO4.2H2.
CSO4.2H2O. Okay, good. CaCO3, any common name?
Limestone.
Limestone. If you are heating that, what will you get?
Quick lime and carbon
Quick.
dioxide.
क्विक लाइम के लिए और कुछ नाम है?
Lime.
गुड, वेरी गुड. ओके, सो CaOH ट्वाइस जो है, ये किस में यूज होता है? CaOH ट्वाइस, इट इज यूज्ड इन व्हाइट वॉश. ओके, जिप्सम जो है 3 जो है, इट इज यूज्ड टू कास्ट स्टैच्यूज. It is used in casts of statues. Okay, NaCl, where is it used?
Washing soda.
NaCl is used for the preparation of washing soda. Okay, for the preparation of washing soda. Can anyone tell me the preparation method of washing soda? Anyone? What is the formula of washing soda?
Na2CO3.
Na2CO3 dot 10H2O. Okay, can anyone tell me the preparation method of it?
मतलब CaCO3 को डिकम्पोज करके CO और CO2 फॉर्म करेंगे, फिर वो NaCl को CO2 के साथ वाटर का NaOH फॉर्म करके फिर CO2 के साथ रिएक्ट करके NaHCO3 फॉर्म करेंगे, फिर उसको हीट करके Na2CO3.
Once again, second step फिर से बताना.
NaCl मतलब NaOH will react with water. Sorry, NaCl will react with water to form NaOH.
NaCl will react with water to form NaOH.
No, NaOH will react with CO2 to form NaHCO3.
NaCl will react with CO2 to form NaHCO3. बिल्कुल गलत है. Any other student?
Sir, may I try?
Yeah, yes, Karthik, go
सर
ahead.
NaCl अमोनिया और H2O का एक मिक्सचर बनाते हैं, उससे कार्बन डाइऑक्साइड पास करते हैं.
कार्तिक ये बताओ, चैतन्य क्या मिस किया?
वो NaCl और CO2 वगैरह नहीं रिएक्ट करते, अमोनिया CO2 और H2O रिएक्ट करके
Exactly.
NH4 HCO3 बनाते हैं.
Exactly. Ammonia will be reacting with CO2 in the presence of H2O. पहले यहाँ से अमोनियम बाइकार्बोनेट मिलेगा, चैतन्य.
हाँ सर.
And H4 HCO3. This will be reacting with NaCl. यहाँ पे NaCl का यूज है to form sodium bicarbonate. The sodium bicarbonate being less soluble, it can be separated, and उसको हीट करने से आपको Na2CO3 मिल जाएगा. Okay, so NaCl यहाँ पे यूज हो रहे for replacing that ammonium ion. Ammonium bicarbonate जो है, it is replaced by sodium and it is converting into sodium bicarbonate. So it is used in the preparation method of washing soda. Is that clear? CaCO3, it is used as antacid. I hope everyone knows that. डाइजेशन के लिए, इंडाइजेशन के लिए कुछ तो लिखा है नोट्स में, यूसेज में। ओके ठीक है, नेक्स्ट। इन कंपैरिजन टू बोरॉन, बेरिलियम हैज आंसर।
D
आंसर
option.
ऑप्शन
D.
डी फॉर दिल्ली। ओके,
हाँ.
डी इज द राइट आंसर। बेरिलियम और बोरॉन, पहले बेरिलियम रहेगा उसके बाद बोरॉन रहेगा। लेफ्ट टू राइट, व्हाट हैपेंस टू जेड स्टार? इंक्रीजेस। So boron has a greater Z star. So beryllium जो है, it has lesser nuclear charge, okay, and greater ionization enthalpy. What is the reason for the greater ionization enthalpy of beryllium when compared to boron?
Fulfilled orbital.
Fulfilled s orbital, or it is also called as penetration effect. In case of beryllium, you are removing the electrons from s orbital to s2. In case of boron, the configuration is 2s2 2p1. A p orbital is less penetrated towards the nucleus when compared to s orbital. So electron removal process from the s orbital becomes more difficult when compared to the removal of electron from the p orbital. Agreed? As a result, the ionization energy of beryllium becomes greater when compared to that of boron. So answer is option D. It has lesser nuclear charge because left to right Z star increases, and it has greater ionization enthalpy because of the penetration effect. Okay, question number 3, thermal stability. Answer
B.
Option B.
option B. Okay, Vardhan, can you tell me how to compare? Vardhan?
Yes, sir.
Yeah, please tell me how to compare thermal stability of these particular compounds.
So they are complex, complex ions, so lattice energy.
Complex anions केस में lattice energy देखोगे?
Sorry, hydration energy.
Okay,
Sir, packing efficiency देखेंगे.
ये solubility नहीं है, ये thermal stability है. Solubility अलग है, thermal stability अलग है. How to compare thermal stability in case of complex anions? Prithviraj?
Covalent character.
We need to see the covalent character. Okay, what is happening to the covalent character down the group?
मतलब साइज जितना है, कैटन का साइज जितना छोटा होगा उतना ज्यादा कोवेलेंट कैरेक्टर होगा। तो डाउन द ग्रुप साइज बढ़ता है तो कोवेलेंट कैरेक्टर डिक्रीज हो, तो थर्मल स्टेबिलिटी डिक्रीज हो।
कोवेलेंट कैरेक्टर डिक्रीज हुआ तो thermal stability increase हुआ. Okay, good. Exactly. This being complex anion, everyone don't forget these things. CO3 2- जो है वो complex anion है. One which is made up of more than one atom is considered as complex anion. In case of complex anion, you need to compare the covalent character. Covalent character जितना ज़्यादा रहेगा, thermal stability उतना कम रहेगा. Ionic compounds will be more stable when compared to covalent compounds because of greater attractive forces. So covalent character ज़्यादा हुआ तो thermal stability कम हो जाएगा. Covalent character increases, thermal stability decreases. Beryllium जो है, यहाँ पे beryllium है, beryllium के बारे में नहीं है. Magnesium जो है, magnesium being smallest cation among the given cations, it will be having the greatest covalent character. If it is having greatest covalent character, its thermal stability will be least. So answer आपको option B रहेगा. Everyone? Okay. Next question. A hydrated solid X on heating initially gives a monohydrated compound Y. Y upon heating above 373 Kelvin. Above 373 Kelvin, which is 100 degrees, right? Above 373 matlab, leads to a anhydrous white powder. Identify X and Z. Answer?
B.
Option B. Washing soda जो है, it is Na2CO3 dot 10H2O. Whenever it is heated, even whenever it is left to air, it will show a property called efflorescence. Efflorescence matlab it will be losing water. So Na2CO3 dot 10 H2O जो है it converts into Na2CO3 dot 1 H2O. उसको further heat करने से is the temperature 373 only? टेम्परेचर आपने हमने एस ब्लॉक नोट्स में जो लिखा है
375 से ज्यादा
373 से ज्यादा होगा तो पूरा वाटर लूज करेगा।
इससे ही ज्यादा है ना? ओके ओके। आई थॉट द फॉर व्हिच द टेम्परेचर इज 120 डिग्रीज प्लास्टर ऑफ पेरिस के लिए ना? टेम्परेचर 120 डिग्रीज का
120
हाँ, इट इज फॉर प्लास्टर ऑफ पेरिस। ओके ओके। 120 डिग्रीज मतलब आपको 393 हो गया, 393। okay, so these temperature conditions are also important. Remember the temperature conditions. Okay, 373 Kelvin पे it is losing that water, that 1 H2O भी lose कर रहा है, it is converting into soda ash. Any doubt? Okay. Plaster of Paris जो है, whenever it is heated above 200 degrees, it will be converting into dead burnt plaster. Okay, that is for plaster of Paris. Or that is for gypsum. Gypsum को 200 degrees से above heat किया तो you will be converting that into dead burnt plaster. Question number 5. Answer anyone? Five answer anyone? The answer is very, very important. In the construction of aircrafts, we use an alloy of magnesium and aluminium. आप लोग NCERT टेस्ट को पढ़ा तो वहां पे रहेगा magnesium and aluminium, and the name of the alloy is magnesium. Combination of magnesium plus aluminium will give you magnesium, which is used in the construction of aircrafts. And this has percentage, आपको 5% magnesium रहता है इसमें. There is only 5% magnesium, and remaining 95% is of aluminium. You can also remember this data. You have 5% magnesium and 95% aluminium, and the name of the alloy is magnesium. Is that clear? Okay, question number 6. The structure of beryllium chloride in solid state and vapor phase respectively are. Answer? Beryllium chloride in solid state and vapor phase respectively are.
Chain and dimeric.
Chain and dimeric, option D होगा.
हाँ
In solid state you are having a polymeric structure, and in vapor phase at a lesser temperature, less than 1200 Kelvin, it exists as a dimer, and about 1200 degrees it exists as a monomer. Okay, vapor phase maybe. So remember the temperature condition too. So chain and dimeric. Any doubt anyone? Question number 7. Magnesium powder burns in air to give. Answer?
Option A हो.
Option A होगा. It gives you combination of oxides as well as nitrites. So option A. If you are having group 1 element, group 1 elements, they cannot form nitrites except lithium. बाकी सब only oxides ही बनाएंगे. This being group 2, all group 2 elements can form nitrites as well as oxides. And down the group, what happens to the ease of formation of nitride? Down the group,
Decrease.
decrease
it decreases. Why does it decrease? Because nitride being smaller, as the size of the cation increases, the stability may decrease. Because of that, down the group, the ease of formation of nitride decreases. Okay, good. 8th, the covalent alkaline earth metal halide is. Answer?
D option.
D option. It has to be D. Beryllium being smaller, उसका पोलराइजिंग पावर ज्यादा रहेगा। बेरिलियम के कंपाउंड जो भी है और लिथियम के कंपाउंड जो भी है, दे विल बी कोवेलेंट इन नेचर। ओके, ठीक है। ओके, या ninth question, answer please. Ninth question. Option
D option.
Option D, मतलब Na2CO3.10H2O जो है, it is called as washing soda, which is prepared using solvay ammonia solvay soda process or solvay ammonia soda process. MgH, magnesium bicarbonate. The bicarbonates of calcium and magnesium, they are responsible for temporary hardness of water. Agreed? NaOH is prepared in Kastner-Kellner cell. Can anyone tell me the advantage of Kastner-Kellner cell?
मर्क्यूरी टायोड्स होते हैं, so NaHg फॉर्म होता है।
Mercury electrode use करते हैं, so NaOH is formed. Sorry, NaMg amalgam is formed. That on dissolution in water, you will be getting NaOH. What is the other cell?
Nelson cell.
Nelson cell. The other cell is Nelson cell, where you have a liberation of Cl2 and NaOH उनके बीच में reaction होके cold condition में आपको सोडियम हाइपोक्लोराइट मिलेगा, NaClO. Okay. Ca3Al2O6, ये जो है, it is a constituent of Portland cement. Okay. अभी Ca3Al2O6, it is nothing but tricalcium aluminate. Tricalcium aluminate. सीमेंट में क्या रहता है आपको? Calcium aluminates or calcium silicates. Remember, it is made up of silicates and aluminates of calcium. Tricalcium aluminate मतलब फॉर्मूला क्या हो जाएगा आपको? You will have that as 3CaO Al2O3, 3CaO.Al2O3. इसी को they have written that as Ca3Al2O6. Ca3 3Cl है, Al2 and oxygen कितने हैं? 6 है. Hence it is written as Ca3Al2O6. But it is exactly tricalcium aluminate, which is a constituent of cement. Is that clear?
Yes.
Everyone? Okay. So यहाँ पे आप लोग ये मार्क कर सकते हो, Ca3Al2O6 is nothing but tricalcium aluminate. 10th, the amphoteric hydroxide is
A.
A.
Okay. Can anyone tell me the reactions of BOH twice with HCl as well as NaOH? दोनों के केस में आपको what do you get? You'll be getting a complex BOH4 whole 2 negative. Remember? BOH twice with acid as well as base. Everyone. ये वाला BOH twice with 2OH minus, आपको BOH4 whole 2 negative. Similarly, BOH twice with HCl and H2O, again BOH4 whole 2 negative और 2Cl ऐसा salt जैसा बना है. Is that clear? So try to remember the products also. Okay, it is amphoteric because it can react with both acid as well as base. Product भी याद किया तो अच्छा रहेगा. 11th question. The metal used for making X-ray tube window is? Answer. Anyone?
Sir, D.
D मतलब कैल्शियम. कैल्शियम के साथ एक्सरे ट्यूब इंस्ट्रूमेंट बनता है, वैसा लग रहा है तुम्हें? ओके, डी फॉर दिल्ली ना?
हाँ सर.
ओके, ऐसा क्यों लगा? कभी देखा क्या एक्सरे मशीन कैल्शियम के साथ बना हुआ दिखा क्या तुम्हें? Any other answer? D is not the right answer. Calcium is not the right answer. Anyone? Anyone? Any guesses? Any guess? If you want to take a guess among these elements, what do you think will be a preferable metal in order to make that particular tube or tube window, X-ray tube window?
BE
Beryllium. Okay, why do you think so?
सर मतलब वो सबसे स्मॉलेस्ट साइज रहता है उसका और उसका आयनाइजेशन एनर्जी भी ज्यादा रहता है तो
Very good. Beryllium being the smallest, it has highest ionization energy. Because of its highest ionization energy, X-rays जो भी है, whenever they fall on beryllium, it won't be ionized. अगर वो ionized हुआ तो वो जो X-ray के जो भी calculations जो भी रहेंगे, they will be interfering. Is that clear? You need to have a metal that cannot be ionized with the X-ray. बाकी सोडियम जो है, सोडियम कैन शो फोटोइलेक्ट्रिक इफेक्ट इवन विद द विजिबल स्पेक्ट्रम करके हमने कहा. मैग्नीशियम और कैल्शियम ये ग्रुप 2 मेंबर्स जो है, दे कैन नॉट शो फोटोइलेक्ट्रिक इफेक्ट विद विजिबल स्पेक्ट्रम. वो तो सही है, बट यहाँ पे हम एक्सरेज डाल रहे हैं ना. एक्सरेज हैज ग्रेटर एनर्जी व्हेन कंपेयर्ड टू द विजिबल रीजन. यूवी रीजन का भी ज्यादा है, यूवी रीजन से भी ज्यादा है एक्सरेज के लिए. एग्रीड? सो बेरिलियम जो है, दैट इज द मेटल व्हिच हैज lesser tendency to ionize. If it is having lesser tendency, obviously preferred option is B. Is that clear? You can also remember this as important use of beryllium. Okay. ठीक है. But if you apply some logic, beryllium has to be a preferred option because it won't be ionized by X-rays. Okay. Next, 12th. The alkaline metal nitrate that does not crystallize with water molecules. Answer, anyone? These are the things for which you need to apply some concepts. You need to apply your logic. क्योंकि ऐसा अलग से हमने पढ़ा नहीं है. This particular molecule won't be forming water of crystallization. What can be the possible answer?
Option C.
Option C. Okay. Why do you think so, Karthik?
Sir, because it will have a higher lattice energy.
It will have a higher lattice energy. Okay, water of crystallization may, we are not breaking the ion. First of all, we are not breaking the compound. You will be simply adding some X amount of H2O, Y amount of H2O, vaisa. Okay, so no question of lattice energy. Any other explanation? Anyone? Any other student?
Sir, it won't be soluble.
It won't be soluble. Okay. वो जो water of crystallization जो भी आ रहा होगा कोई भी ionic compound के अंदर, what is the reason for that? What do you think? Can I say it is because of the high polarizing power or the higher attractive power of the cation? If the cation is attracting the water molecules, they will be coming closer to that particular solid. As a result, they will be attached or they will be attracted towards that particular solid. So can I say the one which has higher charge density, जिनका charge density ज़्यादा होगा, there will be a probability for that to have water of crystallization. Down the group, what happens to charge density? Decreases. If charge density decreases, the tendency for it to attract the water molecules will be decreasing. Okay, so among all these, which has the least tendency to attract the water molecules or which has the least charge density? It is barium positive. Hence the answer is C. आया समझ में? Okay. Question number 13. Which one of the following alkaline earth metal sulfates has its hydration enthalpy greater than its lattice energy? मतलब it has to be soluble करके कह रहे. Hydration enthalpy greater than lattice enthalpy. Solubility के लिए क्या देखेंगे हम? Sulfates में there is no exception. Okay, the only exception you have is in group 1 carbonates and bicarbonates. जो हम order expect करते हैं उसका उल्टा लिखना है आपको बस. Okay, that is for only group 1. Group 2 में कुछ exceptions नहीं है. The only exception is in case of oxalate. Okay, but ये तो sulfate हो गया. If you are having a larger anion, SO4 2- जो है It is a large anion, everyone. If it is a large anion, down the group, what happens to lattice energy? It will be decreasing at a slower rate. What is the reason for that? Because of achievement of packing efficiency. Everyone in the lecture?
Yes, sir.
Okay, this being a larger anion, down the group, there will be achievement of packing efficiency. So lattice energy will be decreasing at a slower rate. If lattice energy decreases at slower rate, so solubility is going to decrease. So one which is least soluble will be BaSO4. They're saying hydration enthalpy greater than its lattice energy. So pehla member jo bhi rahega, which is BaSO4, it is most soluble, na? Everyone, please put your video on. Okay, which is least soluble? Barium sulfate. Which is highly soluble? BaSO4. So BaSO4 mein there is a chance for hydration energy greater than lattice energy. So answer is B. Is that clear?
Yes, sir.
14. Okay, 14. Thermal stabilities. Answer please. Vardhan, अब बताओ thermal stability का order. Even inorganic has logics. If you apply those logics, remember and apply those logics. Most of the things can be solved by logics, but there are some things which you need to remember definitely. ऐसा नहीं है बिल्कुल बिना याद करके only logics के साथ आंसर कर पाएंगे. But this thing, thermal stability, this we need to understand by the concept. We cannot remember the several thermal stabilities orders. Is that clear? Okay. Vardhan, please explain this now. Vardhan, हो क्या lecture में?
Yes, sir.
Okay. Again, carbonate क्या होगा? It is a complex anion.
Yes, sir.
In case of complex anion, what you should see?
Covalent character.
Covalent character. CO3 2 minus जो है, it is complex anion. If it is a complex anion, you need to see for covalent character. More is the covalent character, less will be the thermal stability.
Yes.
Everyone? Okay. So covalent character सबसे ज़्यादा किस में रहेगा? MgCO3. Then you have CaCO3. सबसे ज़्यादा, sorry, यहाँ पे Be भी है ना? You have BeCO3 सबसे ज़्यादा because beryllium has the smallest size. Then you have more covalent character. Tell me the order of covalent character, everyone. Among the given compounds, covalent character का order बताओ. सबसे ज़्यादा BeCO3. उसके बाद
MgCO3.
MgCO3. उसके बाद
CaCO3.
Where do you want me to keep K2CO3? K2CO3 सबसे लास्ट में आएगा. The reason is potassium has only +1 charge, so उनका polarizing power सबसे कम है. Okay, बाकी सब में +2 charge है ना. In general, charge is the more dominating factor when compared to size. Okay, because of the greater charge of other compounds, उनका polarizing power obviously ज़्यादा है और उनका covalent character ज़्यादा है. Okay, K2CO3 सबसे लास्ट में ही आ रहेगा. If this is the order of covalent character, what will happen to thermal stability? इसका उल्टा?
Yes.
Okay, so answer क्या रहेगा? आपको BeCO3 4 less than, 2 less than, 3 less than 1. Option B. Any doubt, anyone? More the covalent character, less will be the thermal stability. I hope this is clear. Next question. Question number 15. The oxidation state of most electronegative element in the products of reaction of BaO2 with H2SO4. Is BaO2 a peroxide? BaO2, barium peroxide, right? Any peroxide on reaction with dilute acid, what will you get?
H2O2.
H2O2. So यहाँ पे आपको H2SO4 के साथ जब रिएक्ट किया है, it will give me H2O2 plus BaSO4, which is the most electronegative element here, oxygen. जिसका ऑक्सीजन स्टेट पेरोक्साइड में -1 है, सल्फेट में -2 रहेगा. सो यहाँ पे ऑप्शन ऐसा नहीं देना चाहिए था, क्योंकि वहां पे -1 एंड -2 भी है, -2 एंड -1 भी है, दोनों सही है ना. If someone is writing H2O2 first and BaSO4 second, -1 -2 रहेगा. If someone is writing BaSO4 first, H2O2 second product, -2 -1 रहेगा. ऐसा ऑप्शन ये BD, both of them are right. It all depends upon which particular product you are taking first. Is that clear? ये -1 -2 रह सकता है या -2 -1 रह सकता है. I hope that's clear, everyone. Okay. Next question. Calcium is obtained by, answer. Electrolysis of molten CaCl2. Okay. Next. ये टेम्पररी हार्डनेस को हटाने के लिए मोर देन वन ऑप्शन हमने पूरा पढ़ा नहीं है. टेम्पररी हार्डनेस को हटाने के लिए आफ्टर रीडिंग अबाउट हार्डनेस ऑफ वाटर करते हैं. बट एज ऑफ नाउ व्हाट इज द थिंग यू नो, COH twice Na2CO3 भी करता है फॉर रिमूवल ऑफ हार्डनेस, NaOCl भी होता है. सो आंसर इज B, C and D. Okay. Magnesium sulfate on reaction with NH4OH, which is ammonium hydroxide, and Na2HPO4 forms. This is the question. Na2HPO4 forms. यहाँ पे how you can understand is NH4OH is a base. First of all, understand that NH4OH, क्योंकि ऐसा नया नया क्वेश्चन तो बहुत कुछ आ सकता है आपको. NH4OH, this is a base, is Na2HPO4 acid. This is an acid because H3PO4 जो है it can give 3 H positive. यहाँ पे आप लोग कितने H positive हटाया? केवल 2 H positive हटाया और एक हाइड्रोजन है ना इसके अंदर. Everyone remember, understand this. H3PO4 can give 3 H positive. यहाँ पे हमने एज ऑफ नाउ 2 ही H positive हटाया और एक H positive है ना. ये बेस है, ये एसिड है. एसिड और बेस के बीच में पहला रिएक्शन क्या होगा? Salt and water. So you will be forming NH4PO4 plus H2O. NH4PO4 जैसा वैसा नहीं लिखना चाहिए आइडियली, क्योंकि वो बैलेंस नहीं होगा. You will be getting NH4 पॉजिटिव अलग, PO4 3- and water. ओके, यहाँ से आपको H positive देके हटा के I have given that H positive to this OH minus. So you got H2O, or else I can write that as, everyone concentrate here. Once again, I'm just modifying this a bit. ये acid है, gives rise to. इसके अंदर से H positive हटाते ही उसके जगह पे you will be having NH4. Na2 को वैसा ही रखते हैं, Na2PO4. Any doubt here? Plus the other product is H2O. यहाँ से H positive हटाया because this is an acid. यहाँ से OH minus हटाया because this is a base. इन दोनों के बीच में रिएक्शन करके H2O बनाया and H positive के प्लेस में NH4 positive चला गया. Is that clear? अभी MgSO4 को इसके साथ रिएक्ट किया हो. Okay. Na positive being more and more electropositive, it will be preferring to present in the solution as an ion. Mg2 positive being less electropositive. Okay, Mg2 positive जो है, it will be replacing that Na positive and it will be converting into NH4 MgPO4 प्लस आपको 2 Na positive ions आ जाएंगे. This is nothing but the precipitate. They are saying it as white crystalline precipitate, na? Why is this happening? Because Na positive being more electropositive, it will try to be in the aqueous solution. Mg2 positive being less electropositive, it will be forming the precipitate. यहाँ पे white crystalline precipitate बन रहे करके बोला है. You cannot have, if you have Mg2 positive also in the system, you cannot have Na positive precipitating rather than Mg2 positive. समझ में आ रहे हैं? Precipitate मतलब it is coming
हाँ
out
सर.
has some salt. Na positive being more electropositive, it will always try to be in the aqueous solution. I hope that's clear. Understand that. So what will be the product? It will be MgNH4PO4. Option A. Option A. Is that clear? Okay. I hope every one of you knows this information. Question number 19. The material used in solar cells. What is used? Silicon?
Silicon.
Okay, because it has very good semiconductor properties. Silicon is a semiconductor. Semiconductors आपको फिजिक्स में अलग से चैप्टर ही रहता है सेमीकंडक्टर्स करके. सो उसमें आप इन डिटेल सेमीकंडक्टर्स के बारे में पढ़ सकते हो. केमिस्ट्री में जरूरत नहीं, काफी है. इज दैट क्लियर?
हाँ सर.
Okay. I want you to solve only one question from this. 26th question बता देना answer. Arrange the following in increasing order of their basic strength. Increasing order of their basic strength, starting from the least basic compound, arrange in increasing order of basic strength. Answer anyone? Answer please. हमको क्या पता? What is the general information? Non-metallic oxides. Non-metallic.
H2O, K2O, SRO, MgO and NiO.
Non-metallic oxides जो है वो acidic होंगे. Metallic oxides जो है वो basic होंगे. Okay. अगर metallic nature ज्यादा है तो the basic nature is going to be high. अगर non-metallic nature ज्यादा है तो the acidic nature is going to be high. Okay, चैतन्य तुमको आंसर पता है. What is the answer?
NiO, फिर MgO, SRO, K2O और CS2.
NiO is lesser than, MgO is lesser than, K2O lesser than.
SRO आएगा सर.
नहीं, SRO फिर K2O.
सर पहले SRO फिर K2.
Okay. पहले SRO फिर
K2 और फिर CS2.
फिर CS2. I think this is the right answer. देखो ये तो निकल हो गया. निकल is a d block element which is not so metallic. Okay, S block elements are more and more metallic. Metallic oxides are basic. As this is having less metallic nature, it is less basic. उसके बाद group 1 elements are considered to be more basic when compared to group 2 elements because of their lesser ionization energy values. So ये दोनों group 1 हो गया, ये दोनों group 2 हो गया. And down the group, what happens to metallic nature? It increases. As a result, SRO जो है, it is more basic when compared to MgO because this is more metallic oxide when compared to MgO. Understood? And these two are more metallic when compared to group 2 elements. And K2O, CS2O में CS will be more metallic because down the group metallic nature increases. Is that clear, everyone? Okay. If you have any doubt, you can ask me. Metallic nature में CS का सबसे ज्यादा है, down the group metallic nature increases. इन दोनों में कैसे कंपेयर कर रहा हूँ? Using group 1. Group 1 में down the group, in any group down the group metallic nature increases, so CS2O ज्यादा है K2O में. इन दोनों को इनसे कैसे कंपेयर कर रहा हूँ? These two being group 1 elements, they are more metallic when compared to group 2. इसलिए इन दोनों को ज्यादा ही रहना चाहिए इन दोनों से. इन दोनों में कैसे कंपेयर किया? Strontium is below magnesium, down the group metallic nature increases or the base strength increases. Nickel being a D block element, it will be least metallic among the given compounds. Is that clear, everyone? Okay.
Yes, sir.
Okay, then this is about S block. S block के हमने group 1 के भी practice किया है, group 2 के भी practice किया है. While practicing, बीच में हम कुछ important points encounter किया है. Please mark them in your notes. Like the usage of magnesium in the construction of aircrafts, use of beryllium in the preparation of X-ray tubes. Okay. And कुछ reactions, ऐसा कुछ reaction समझो इनके बारे में. Okay, please add them. Okay, then let's go to P block again. We have already started P block. Everyone, please put your video on and concentrate. P block में हमने metals, वहाँ के non metals और metalloids या semi metals उनको list out किया है. Once you mark the P block, in elements जो है, these are metalloids और semi metals. इसके ऊपर जो भी है, these are non metals. इसके नीचे जो भी है, those are metals. Is that clear? So carbon, nitrogen ये सब आपको non metals हो गया. ये वाले आपको metalloids हो गया, semi metals हो गया. All these will be metals. Okay, then we have seen some general properties. Boron is considered as more non-metallic, even though it is semi-metal. It is considered as more non-metallic when compared to metallic. Rest all of them are metals. In the boron family, boron has more non-metallic nature, and rest all of them are having metallic nature. Physical nature में boron has two allotropic forms, alpha and beta. Beta being more stable. Okay. Down the group, the metallic bond strength decreases. As a result, softness increases. So gallium, indium, thallium जो है soft metal से, aluminium is considered to be hard. Even boron, even though it is non-metal, it is considered to be hard because of its chained polymeric structure. Is that clear? Okay. Melting and boiling points. Melting point में आपको एक चीज याद रखना है. Gallium तक the melting point decreases. After that, the melting point increases. In case of boiling point, there is no ambiguity. Down the group, the boiling point decreases. Is that clear, everyone? Okay. And the highest melting point of boron or high melting point of boron is due to its chained covalent polymeric structure. Even though it is non-metal, it is having a chained covalent polymeric structure in solid as well as liquid states. Hence, it is having a significant amount of melting and boiling points. Clear है सबको? Okay. Atomic radii के बारे में discuss किया, important है. In case of atomic radii, down the group, we expect the atomic radii to increase. Based on that, we need to conclude gallium should be having a greater atomic radii when compared to aluminium because of greater number of shells in gallium. Gallium में 4 shells है, aluminium में आपको 3 shells है. But when we compare Z star, just before gallium, we will fill 10 electrons in the 3D subshell. because of which there is significant increase of the Z star. So based on Z star, if I want to compare, the atomic radius of gallium must be lesser than that of aluminium. So there are two factors which are counterbalancing. So because of that, the atomic radius of gallium becomes almost equal to that of aluminium. वैसा कुछ लिखते हैं हम. Exact order में देखा तो gallium का थोड़ा सा कम रहता है. It is not significantly lesser. Gallium is slightly lesser than aluminium. Hence this becomes the order. Ionization energy में again दोनों का size similar होने की वजह से and Z star of gallium being higher, the ionization energy of gallium becomes higher. Down the group, we expect the ionization energy to decrease, but gallium का ज़्यादा रहेगा because of its equal or lesser size that of aluminium and greater Z star. So boron is greater than aluminium. Aluminium is lesser than gallium. Gallium is again greater than indium. Indium again becomes lesser than thallium because of presence of 14 4f electrons and 10 3d electrons just before thallium. Okay, so thallium के अंदर 14 4f electrons है. Again उसका Z star significantly increase हो जाएगा. Because of that, the ionization energy also increases. Or else ऐसा याद रखो, in group 13 you have an oscillating trend of ionization energy. Increase, decrease, increase, decrease. So there is an oscillation. Is that clear?
Yes, sir.
Okay. Then we have seen oxidation states. Group 13 elements के common oxidation states. Group 1 के लिए you have only one oxidation state which is +1. Group 2 elements के लिए again you have only one oxidation state which is +2. But for group 13 elements you have two common oxidation states. ये दो ही हो सकता है, इनके अलावा और कुछ नहीं रहेगा. Okay. If only p electrons are participating, केवल p electrons bonding में participate कर रहे तो it will be having +1. If both p and s, all the electrons of s and p are participating, then it will be having +3. Okay, +1 and +3. And in general, in the p block, group 13, 14, 15 लिया तो आप लोग, down the group, the stability of lower oxidation state increases and the stability of higher oxidation state decreases down the group. And for the last element or for the 6th period element, उसका lower oxidation state का stability becomes higher when compared to the higher oxidation state. मतलब यहाँ पे last element thallium है. Okay, down the group, the stability of higher oxidation state is decreasing. मतलब B+3 is greater than, Al+3 greater than, Ga+3, so on and so forth. And the stability of lower oxidation state is increasing. So B+1 is less than, Al+1 less than, so on and so forth. And for the last element, its lower oxidation state, उसका खुद का lower oxidation state is supposed to be or will be more stable when compared to its higher oxidation state. So thallium में उसका +1 ज़्यादा stable होगा +3 से. This particular point, thallium's +1 oxidation state is more stable than +3. Is that clear? Okay. And boron का +3 is ज़्यादा stable है, so all of its compounds has +3 only. Aluminium, gallium, indium का +3 ज़्यादा stable है when compared to +1, but +1 भी exist होता है. Okay, but stable कौन है? +3 ज़्यादा stable है +1 से. Only in last element, the lower oxidation state becomes more stable than the higher. Is okay. As में इनका +3 ज़्यादा stable होने की वजह से this gallium and indium +1 oxidation states this disproportionates. मतलब +1 into +3 and 0 में convert हो गया. Reason क्या है? Gallium और indium का इनका +3 ज़्यादा stable है +1 से. आ रहे समझ में? Everyone in the lecture? Okay. Thallium compounds resemble alkali metals compounds. मतलब thallium +1 जो है, it will be forming a hydroxide similar that of alkali metal hydroxides. TLOH similar to that of NaOH. It is also a strong alkali. Alkali metal compounds में और alkali metal ions में +1 oxidation state वाले. Apart from lithium sulfate cannot form any alums, but rest all other forms alums. वैसा यहाँ पे Tl+1 जो है, उसका सल्फेट जो है, it is also forming alum or double salt. Is that clear? Okay, good. As Tl+1 is more stable As Tl+1 is more stable, it is spontaneously converting into the +3 oxidation state is converting into +1. Hence, it is acting like a good oxidizing agent. What is meant by oxidizing agent? खुद reduce होगा. खुद reduce क्यों हो रहा है? Because इसका +1 ज़्यादा stable है +3 से. So it is accepting electrons. Is that clear, everyone? Okay. Everyone alert, right? नींद नहीं आ रही ना इनऑर्गेनिक की वजह से? Okay. Shall we go to the next part then? यहाँ पे आपको जनरल इंफॉर्मेशन लिखा है पीरियड 6 एंड 7 में लास्ट एलिमेंट्स में. पीरियड 6 मतलब थैलियम हो गया. थैलियम में ही +1 ज्यादा स्टेबल है तो उसके नीचे वाले में भी उसका +1 ज्यादा ही स्टेबल रहेगा. एग्रीड? बट थैलियम तक ही पढ़ते हैं, उसके नीचे एलिमेंट्स के बारे में हम पढ़ते नहीं है. बट उसके नीचे वाले एलिमेंट में भी इसका लोअर ऑक्सीडेशन स्टेट विल बी मोर स्टेबल देन हायर ऑक्सीडेशन स्टेट. ओके, so for period 6 and 7 always LOS indicates lower oxidation state is more stable than its higher oxidation state. For other periods उनके above जो भी रहेंगे 4, 5 या 3, 4, 5 इनके lower oxidation states are less stable than higher oxidation states. Is that clear? यहाँ पे 3 you can also add 3, 4, 5. Okay, ठीक है. गैलियम जो है GaCl2 compound में it appears to show a +2 oxidation state, but actual में उसमें भी वो +3 में ही है as well as +1 में है. GaCl2 जो है exists as a complex. It exists as GaCl4, where inside Ga is having +3 oxidation state, outermost Ga is having the +1 oxidation state. So +3 और +1 दोनों exist हो रहे हैं यहाँ पे. Any doubt? Okay, let's go to the oxidation potential. Oxidation potential. What is meant by oxidation potential? Oxidation होने की tendency और capability. Okay. If I am talking about oxidation potential, I will be referring to reducing nature. अगर खुद oxidize हो रहे तो दूसरे चीज को reduce करेगा. Okay. Boron जो है, being smaller. If it is smaller, its ionization energy will be significantly higher. And हमने group 1 elements में ऐसा कुछ बात किया. All these oxidation potentials or reduction potentials, they are measured in aqueous solutions. Remember? Measured in aqueous solutions. If they are measured in aqueous solution, you also need to consider the effect of hydration energy. Agreed? अभी ये जो boron 3 positive जो भी रहेगा, it has the highest amount of ionization energy as well as it has the highest amount of hydration energy. Lithium के केस में हमने क्या किया है? Lithium positive के केस में we have made lithium positive, or we concluded that lithium positive is the strongest reducing agent in the aqueous solution. What is the reason for that? Because of its highest hydration energy. हम group 2 में ऐसा कुछ differentiation तो नहीं देखा. जो नॉर्मली हम एक्सपेक्ट करते हैं डाउन द ग्रुप रिड्यूसिंग नेचर इंक्रीजेस, वही आया है यहाँ पे भी. इन दिस केस आल्सो बोरॉन जो है इट इज पुअर रिड्यूसिंग एजेंट इवन दो इट हैज वेरी गुड हाइड्रेशन एनर्जी. B3 positive will be having the highest hydration energy. Even though it has highest ionization energy, it is considered as poor reducing agent because of its ionization energy. क्योंकि B3 positive 3 इलेक्ट्रॉन्स निकालना बहुत ज्यादा एनर्जी लगेगा. So the ionization energy is becoming more and more significant for boron when compared to its hydration energy. Hence, it is considered as poor reducing agent, or it has the lowest oxidation potential. Okay. Reason क्या है? Because of due to its higher ionization energy values. Any doubt anyone? बाकी सब में डाउन द ग्रुप ionization energy डिक्रीज होगा ना. ionization energy डिक्रीज हो रहे हैं बट उनका hydration energy significant होने की वजह से they are acting as quite good reducing agents. Others has quite high oxidation potential due to high hydration energies. Is that clear? उनका ionization energy relatively कम हो गया but hydration energy significant amount है. Hence they are acting as good reducing agents और उनका oxidation potential अच्छा है. सबसे ज़्यादा among other elements of group 13 other than boron, which element will be having the highest hydration energy? बोरॉन को छोड़ के Aluminium. Everyone in the lecture, everyone please put your video on. ये जो aluminium 3 positive जो है, being smallest, its hydration energy will be better when compared to the other elements down the group. Okay, so aluminium जो है, it acts as very good reducing agent. In fact, it becomes a better reducing agent than carbon. Very important point to note here. Aluminium जो है, it becomes even better reducing agent when compared to carbon because of its significant hydration energy. हमने common metallurgical processes में क्या देखा? We have seen reduction of the compounds using carbon or carbon monoxide. कार्बन या कार्बन मोनोऑक्साइड से भी बेटर कौन रहेगा करके यहाँ पे लिखा है aluminium. Okay, so if you remember in S block for the extraction of calcium, electrolysis of molten CaCl2 तो किया हमने, उसके अलावा we have written a thermite process where we have used aluminium. यहाँ पे aluminium का oxidation ही तो हुआ है. Aluminium which is 0 oxidation state, it is converting into +3 here. Converting into +3. So here aluminium is acting like reducing agent. Reducing agent, and it is better than carbon. Is that clear? Okay, we also understand this property of aluminium in the chapter of metallurgy, जहाँ पे metals का extraction करेंगे, carbon के साथ भी देखेंगे, कुछ aluminium के साथ भी देखेंगे. We will see when aluminium is preferred over carbon. We will understand that, okay, in detail, conceptually. But यहाँ पे आप लोग समझ में आ रहे हैं? The high reducing nature of it is because of its high hydration energy. Is that clear? Okay, understand. Remember this particular point. Aluminium is used for extraction of many metals, okay, which are highly electropositive. Like calcium को अभी वहाँ पे हमने calcium के extraction में देखा है. Next, halides. Very important halides. Boron के halides जो भी है, because of high polarizing power of boron, they will be covalent. बाकी सब जो है, they have both covalent as well as ionic nature. Okay, remember this, they have both covalent as well as ionic nature. They will be covalent if it is anhydrous medium. They will be covalent in anhydrous medium. Aqueous solutions में, if it is covalent, in general वो bond break नहीं होना चाहिए या ions में बनना नहीं चाहिए. Or else they should be having a hydrolysis. Everyone, if it is covalent, understand this, if the molecule is covalent, whenever I'm putting that in water, it should not convert into ions, A positive or B minus ऐसा. It will be having some hydrolysis. It will be reacting with water to form some AH and BOH. ऐसा कुछ बनता है. अगर covalent है तो. Ionic है तो क्या होगा? They will be splitting into ions. Understood? Okay. अभी यहाँ पे these are considered as ionic in aqueous solutions because they split into their corresponding ions. The reason for conversion of the into corresponding ions is because of their high hydration energy values. Okay. In anhydrous medium, they will be acting like covalent. Matlab their covalent nature will be more when compared to ionic nature. Whenever I am putting them in water, they are acting like ionic. They are acting like ionic because they are able to split into ions. Is that clear? अब यहाँ पे और अच्छे से समझने के लिए, if you take boron halides, these are covalent. Covalent का मतलब क्या है? जब पानी में मिलाता हूँ तब ions में नहीं बनेगा. Whenever you have any covalent species, these being covalent, इनको पानी में डालने से आपको hydrolysis हो रहा है, which is not the case with the other halides. बाकी halides को पानी में डालने से आपको ions में break हो जाएंगे. This being covalent, उसका hydrolysis होके everyone H positive Cl minus के साथ चला गया, OH minus boron के साथ आ रहे, इसलिए H3BO3. H3BO3 is nothing but you can write that as BOH thrice. Okay, 3 बार OH अटैच कर दो. That is nothing but H3BO3. H3BO3 का स्ट्रक्चर बाद में देखेंगे, which is nothing but boron, आपको OH, OH और OH. Understood? Hydrolysis मतलब breaking with the help of water. You are breaking that with water. Why? What is the need for breaking it with water? Because it is not converting into ions on its own. So H positive इसके साथ जाके HCl, HBr, HI मिला, और OH minus इसके साथ जाके you are forming that H3BO3 or BOH thrice. Understood? What is the important point to remember here? Boron will be forming covalent halides. Rest all other are forming covalent as well as ionic. Covalent in case of anhydrous, ionic in case of aqueous. Okay. Next, all of them can act as Lewis acids. Why are they acting as Lewis acids? Everyone, they are electron deficient. Each and every one of them is electron deficient. Why are they electron deficient? उनके outermost electrons 3 हैं. They are forming 3 bonds. So अभी outermost electrons कितना हुआ है? 6. If you are having octet incompletion, they will be electron deficient. Others also, please put your video on. Prithviraj, केवल Prithviraj अच्छे से सुन रहे lecture. I feel like I am having 1-to-1 session with Prithviraj, which is good. Which is good for Prithviraj. Others, please put your video on. Okay. क्या कह रहा था मैं? हाँ. All these are electron deficient. Why are they electron deficient? Because in K, boron, aluminum, gallium, indium, thallium, the outermost electrons. What is the outermost configuration? It is NH2NP1 na? NH2NP1. So outermost electrons कितने हैं? 3 electrons. All the 3 electrons are forming 3 bonds. So 3 plus 3 आपको 6 हुआ, which is octet incomplete. Being octet incomplete, they are electron deficient. Hence, they can act as Lewis acids. But if I want to compare the Lewis acidic strength, down the group it decreases. What is the reason for that? As the size is increasing. Size increase होने की वजह से Lewis acidic strength कम क्यों हुआ है? Whenever the size increases, whenever I have to give electrons, I need to give electrons in the orbital, which is spread in a larger region. Okay, if the orbital is concentrated, उसमें readily देना better होगा या easy होगा, or it will be having tendency to accept electrons into that orbital, rather than giving the electron in the orbital which is spread in a larger region. Agreed? समझ में आ रहा है? As you are having a larger region, that particular donation of electron will be more difficult. Okay, if the electrons are, or if the size is smaller, if the size is smaller, ऐसा भी सोच सकते हैं, if the size is smaller, the electrons which I am giving will be closer to the nucleus. If the size is larger, the electrons which I am giving will be far from the nucleus. So accept करने का tendency भी घट जाएगा. Understand it in 2 different ways, because the other reason which I am saying that the electron is given in a larger orbital, so the electron or the tendency for the electron to go into that particular orbital will be less. Is that clear? So very, very important. Lewis acidic strength down the group, it decreases. Why is it decreases? Why is it decreasing? As size is increasing. Okay. Next, boron halides mein. In case of boron halides, they will be asking, this question is very, very important. Standard question hai. Boron halides mein Lewis acidic strength. If you take BF3, BCl3, BBr3, Bi3, we understood the concept of back bonding in chemical bonding. अभी boron में the orbital is 2p orbital, and fluorine का boron, fluorine, fluorine, fluorine. यहाँ पे electrons, lone pair of electrons जो भी है, they are given into the vacant orbitals of boron in back bonding. रिमेंबर, as a result बोरॉन और फ्लोरीन के बीच में आपको डबल बॉन्ड कैरेक्टर आएगा. एंड इन दिस केस द बैक बॉन्डिंग इज बिटवीन, यहाँ पे 2p ऑर्बिटल है, ये भी 2p ऑर्बिटल है. बोथ ऑफ देम आर स्मॉलर ऑर्बिटल्स, सो इन दोनों के बीच में ओवरलैप जो है इफेक्टिव रहेगा. ओके, सो 2p बैक बॉन्डिंग is best, and in case of BCl3 you have 2p 3p, so the difference in size is more. ये 2p हो गया, ये 3p हो गया. बाद में in case of bromine it is 2p 4p, the difference in size is further greater. 2p 5p, the difference is size is highest. So यहाँ पे ये जो overlap है, ये क्लोरीन के लोन पेयर ऑफ इलेक्ट्रॉन्स या बोरॉन का ऑर्बिटल, दिस ओवरलैप इज पुअर व्हेन कंपेयर्ड टू 2p 2p. 2p 2p में क्या है आपको, द साइज ऑफ द ऑर्बिटल्स इज सिमिलर. ओके, यहाँ पे इफेक्टिव ओवरलैपिंग है. सो इफ बोरॉन इज एक्सेप्टिंग इलेक्ट्रॉन्स फ्रॉम फ्लोरीन इटसेल्फ, will that act like a Lewis acid or will that be accepting electrons readily from the external reagent? No, right? क्योंकि अंदर ही इसका satisfy हो गया octet. Okay, as a result the Lewis addition decreases, and यहाँ पे the completion of octet is not so efficient because the overlap is very, very poor. So this will be having the highest tendency to accept electrons from the external reagent. Agreed? So which is the strong Lewis acid among these boron halides? Bi3 will be the strongest because the back bonding is poor. BF3 will be the weakest Lewis acid because of effective back bonding. Is that clear? Okay. Next. अब यहाँ पे because of this back bonding, BF3 का hydrolysis भी नहीं होता. If you observe, मैंने hydrolysis का केवल BCl3, BBI3, BI3 का ही लिखा है water के साथ hydrolysis का equation. I have not marked BF3. The reason for that is because of the back bonding, ये double bond character significant हो जाएगा. So that particular double bond may not be broken whenever the water is added. क्योंकि strong हो गया ना, so water उसको break नहीं कर पाएगा. अगर water break किया तो you can form this H3BO3 or BOH thrice. This bond being strong, it is not breaking. Okay, so with water, it does not undergo hydrolysis, rather forms an addition product. Addition product मतलब यहाँ पे ये जो lone pair रहेगा, water के अंदर जो lone pair है, that lone pair will be given into vacant orbital of boron. उन दोनों के बीच में बॉन्ड बन रहे हैं. सो यहाँ पे OH माइनस जैसा ब्रेक हो गया, H positive. I am breaking that H2 as H positive and OH minus. That OH minus I am giving the electrons into vacant orbital of boron. Okay. So back bonding में केवल एक बॉन्ड है, ये वाला बॉन्ड ब्रेक होके ये इसके साथ बॉन्ड बनाया, एडिशन प्रोडक्ट. दिस इज कॉल्ड एज एडिशन प्रोडक्ट. ऐड कर रहा हूँ दोनों को. इज दैट क्लियर? ओके. अगेन ये H पॉजिटिव फर्दर और एक H2O के साथ भी ऐड करके H3O पॉजिटिव में कन्वर्ट हो रहे हैं. बिकॉज इन वाटर यू कैन नेवर हैव एग्जिस्टेंस ऑफ ओनली H प्लस आयंस, क्योंकि H प्लस मतलब उसके अंदर इलेक्ट्रॉन्स नहीं है, अनस्टेबल है. H plus will always be attached to a water molecule whenever you have H positive. पानी है तो पास में, उसके साथ कंबाइन होके H3O पॉजिटिव जैसा ही रहता है. Is that clear? Okay. This is one of the important observation. BF3 का hydrolysis नहीं होगा. They will ask that as a theoretical question. Why does BF3 doesn't go hydrolysis, but rest all other boron halides undergoes hydrolysis? The reason is because of significant back bonding. The double bond will be having a greater bond energy, which we cannot break with the help of water. Okay. BF3, due to its great resistance to hydrolysis, used as Lewis acid catalyst in Friedel-Crafts reaction. ये जो Friedel-Crafts reaction में Lewis acid catalyst करके कुछ तो दिया है. We will understand about this in organic. Organic में समझेंगे soon. From Feb we will be starting organic, तो वहाँ पे समझते हैं. Is that clear? Okay, it is used as a Lewis acid catalyst in the reaction of Friedel-Crafts reactions. देखते हैं Friedel-Crafts reaction क्या है, देखते हैं बाद में. Next, other halides. The fluorides of aluminium, gallium, indium, thallium are largely ionic fluorides. Reason क्या है? Fluoride smaller anion है. Being small, उसका polarizability क्या रहेगा?
कम रहेगा.
कम रहेगा. अगर polarizability कम है तो उसका कोवलेंट कैरेक्टर भी कम होगा. So ये जो है, they are significantly ionic fluorides. Fluorides of aluminium, gallium, indium, thallium are ionic. If you go down the group, the size of the anion increases or the covalent character increases. So other halides, fluorides, bromides, and iodides are largely covalent when anhydrous. Okay, are largely covalent when anhydrous, hence can be hydrolyzed. Anhydrous में. Is that clear? Okay. Aluminium AlX3, हाँ. Aluminium के नीचे बोरॉन तक there will be significant back bonding. बोरॉन से नीचे जो भी है aluminium ये सब, because of presence of larger orbitals, the back bonding tendency will be decreased. Aluminium halide, gallium halide, indium halide, thallium halide do not show effective back bonding due to increased size. इनमें कभी भी back bonding नहीं रहेगा, hence they will be forming dimers. Okay, so AlCl3 जो है, as there is no significant back bonding. यहाँ पे आप लोग ये चीज अलग से याद रखना. Even though aluminum is having 3p orbital, fluorine is also having 3p orbital. 3p, because of similarity in size, you may expect a good amount of back bonding, but size बड़ा होने की वजह से the orbital itself is inefficient. Smaller orbitals है तो electron density concentrated रहेगा. So whenever you are having back bonding, ये 2p हुआ तो, or already the size of the orbital is lesser. So the electron density will be concentrated in these orbitals. Whenever there is back bonding, it will be effective. यहाँ पे आप लोग ऐसा कुछ लग सकता है, even though the size is similar. Size similar रहा तो हमको ऐसा कुछ लग सकता है, the back bonding should be efficient. But the orbital nature itself is poor. मतलब the electron density is distributed. If the electron density is distributed, whenever there is overlapping, the overlapping won't be effective. Is that clear, everyone? So only हम 2p के back bonding भी effective consider करेंगे हमेशा. Okay, I hope this is clear. So as it is not having back bonding, it is dimerizing. Al2Cl6 जैसा बनता है. ये already हमने पढ़ा है ना, bridge bond बनता है. Okay, you can represent. Okay, यहाँ पे mark किया है. It is forming a dimer. The dimer is formed in vapor state or in non-polar solvent. The vapor is formed. Sorry, the dimer is formed in vapor state or in non-polar solvent. Polar solvent में फिर से break हो जाएगा. आगे reactions लिखा है, show करता हूँ. So if it is a monomeric state, you are having a vacant p orbital, it can act as Lewis acid. If you are forming, suppose if you are forming a dimer, in that case what is happening? इसके lone pair जो है इसको दे देंगे, इसके lone pair इसको दे देंगे. So it is having 8 electrons. If it is having 8 electrons, उसका octet complete हो गया. So it cannot act as a Lewis acid. In dimer form Al2Cl6 or in dimer form of AlCl3, it is not a Lewis acid. Only the monomer form is Lewis acid. Okay. If it is a Lewis acid, it will be a monomer. Dimer form जो है Al2Cl6, it cannot act as Lewis acid. What is the reason for that? Because the octet is getting completed. Okay. Is B2H6 Lewis acid? Is B2H6 Lewis acid? B2H6 में what is the nature of the bridge bond?
3 center 2 electron.
3 center 2 electron bond है. Whenever you have 3 center 2 electron bonds, वहां पे आपको pseudo stability मिलेगा. It is not exactly completion of octet. So it is still a Lewis acid. B2H6 is the Lewis acid, but Al2Cl6 is not a Lewis acid. Remember this. Okay, because the nature of the bond here is, it is 3 center 4 electron bond. वहां पे आपको 3 center 2 electron bond है, वहां पे pseudo stability है, यहाँ पे stability मिल रहा है. Is that clear? Further, you can also remember these things. इन दोनों के बीच में bond angle 118 degrees है, इन दोनों के बीच में 101, इन दोनों के बीच में 79. ये जो ब्रिज बॉन्ड का बॉन्ड लेंथ 221, रीजन ये 3 सेंटर 4 इलेक्ट्रॉन बॉन्ड है ना, 3 सेंटर्स कंट्रोल कर रहे हैं. दिस इज नॉट ए सिंगल बॉन्ड कैरेक्टर, ये सिंगल बॉन्ड है ना, सो दिस विल बी स्ट्रॉन्गर व्हेन कंपेयर टू दिस. एग्रीड? इफ दिस इज स्ट्रॉन्गर, उसका बॉन्ड लेंथ कम रहेगा, इसका बॉन्ड लेंथ ज्यादा रहेगा. At least understand that this should be having a greater bond length when compared to this, because here you are having 3 centers 4 electron, 3 center 4 electron bond. Agreed? Is that clear? यहाँ पे 2 center 2 electron bond है. I hope this is clear, क्योंकि यहाँ पे एक cloud banana bond जैसे बनता है ना, वही 4 electrons इन 3 के बीच में distribute हो रहे हैं. So bond length, obviously it will be greater when compared to this bond. So at least remember the order, which should have a greater bond length. Bridge bond has a greater bond length when compared to the terminal bonds. ऐसा लिखता हूँ. Bridge bonds or bridge bond length is greater than terminal bond length. Any doubt? Any doubt, anyone? Okay. Down the group, the dimerization ability decreases. Again, why does it decrease? ये जो electrons देना है, if I am giving that in a larger atom, obviously the larger atom will be having lesser tendency to accept the electrons. So dimer बनने का tendency भी decrease हो जाएगा. Any doubt? Agreed, everyone? Okay. Thermal stability. These are simple anions. Simple anions के केस में you need to compare based on lattice energy. Down the group, मतलब ये chloride, bromide, iodide, lattice energy is decreasing. If lattice energy decreases, thermal stability decreases. So thermal stability decreases. Understood? Is that clear, everyone?
Yes, sir.
Okay. चैतन्य, एग्जैक्ट जब क्लास छोड़ने का टाइम आया तब वीडियो ऑन किया तुमने?
नहीं सर.
ये तो अच्छा टैलेंट लग रहा है. ठीक है. We will again understand this particular information is important. We will understand this in next lecture. We will again understand all these things about these halides. Halides of group 13. You may have different types of questions from this. So please understand these 2 pages. अभी हमने जो भी किया है clearly. Okay. I'll post the notes. Understand how I am analyzing things. You also analyze in the same way and try to remember things. Okay. Thank you. Thank you, everyone. From tomorrow, we may start offline lectures. And if we start with offline lectures, the exam is going to be offline. Okay.